Essentially, that's happening on because of two reasons. One is that almost all or majority of new hardware infrastructure spend or new software spend is happening completely on the cloud, but also existing new projects are moving on to the cloud in large companies. And of course, there is a huge amount of migration, which is also happening. Cloud, of course, gives us great advantages. No need to talk about that. It is basically a pay-as-you-go model. There is no need for heavy capex to be invested into companies. It gives you the flexibility to deploy resources and services as and when you need them. So no need to kind of over provision anything. It gives you the speed and agility so you can scale up or scale down as your business requires you to. Of course, and over the last 4 or 5 years, we've seen the huge shift towards AI and machine learning, which requires significant cloud resources, whether it's for compute or whether it's for storage or networking related capabilities. And I think a lot of it has been fueled because of the availability of on-demand infrastructure with cloud. So this basically accelerates the shift towards cloud. And then because of all of this, companies can innovate much faster. We are seeing new business models emerge, new technology frameworks emerge, because it's easier to start and build them on the cloud. The cost of failure is not that high. You don't sink in irrecoverable costs. You can start something, it works, it scales. If it doesn't work, you've just kind of burnt a little bit of OpEx. And that's the reason we are seeing this huge shift towards the cloud. But the challenge also is that as the industry matures with cloud, we are seeing a more complete picture of the cloud life cycle on a company's economics. Cloud clearly delivers on its promise early in a company's journey, right? We're seeing a lot of startups just born in the cloud. They say that if you're starting something new and you're not in the cloud, you probably are crazy. So there's a huge shift towards cloud. So that's why we are seeing startups born in the cloud, but also in very traditional age-old companies, they're starting most new projects on the cloud itself. So cloud clearly delivers on its promise early in a company stage. But then the pressure it puts on margins can start to outweigh the benefits it provides, right? As the company scales and the growth slows down, the cost ROI kind of advantage starts peaking out, and that is where companies start realizing on how much are they spending on cloud versus the acceleration which they're getting in terms of growth. And because this shift generally happens in a slightly later stage in a company's life, it is difficult to reverse it, as it's a result of years of development focused on new features and really not focused on infrastructure optimization. So what's happening is that on the early years, you basically grow with cloud. As the growth slows down and you're looking to optimize, it's very tough because you've already put a large part of your critical infrastructure on the cloud. So there's now a very growing awareness on the long-term cost implications of the cloud. Cost of cloud now contributes significantly to the total cost of revenue, or cost of goods sold, as we call it. Different companies have different ratios on this. If you're talking about large companies, the problem kind of starts to become really big. If you're operating at scale, the cost of cloud can almost double your infrastructure bill, right? So as you can see on the slide, that at times the companies can incur as much as 50% of their cost of revenue on their committed cloud usage. So that was around cloud. So today we are really talking about how can you predict in future, what is your cloud spend going to be, and that really is all about forecasting. Forecasting is not new. Companies have been doing forecasting for a really long time. But the challenge with forecasting is a couple of things, right? One is really accuracy, and it comes from the fact that essentially you use historical data to do some, to predict your future, essentially. So you take historical data, do some trending on it, and forecast a future quantity. Now, that is where accuracy starts coming in. If you take, let's say, a simple thing like a demand forecast, I'll come to cloud cost in a bit. Apart from your historical data, your demand is influenced by many things. It could be rainfall or weather or macroeconomic factors or your pricing or your discounting or your TV ad spend, etc. None of that gets taken. None of the external factors get taken as you build that forecast, and that is why accuracy, takes a big hit. Similarly, when you try and forecast your IT infrastructure costs, cloud in particular, you could take your historical trends and probably get an estimate of what you're going to spend. Like you know which are your peaks and troughs, and you probably can provision for it. But real-time business inputs, right? So if you're an e-commerce company, how does the Black Friday impact you, or how does the lockdown in a certain state impact you, or availability of delivery slots impact you? So your business realities rarely get implemented into your forecasting, and that's why you aren't able to predict it accurately. The other problem is around granularity, right? Again, I'll take the demand forecasting example to illustrate this a little bit more, and we can then translate it into cloud cost forecasting. If you're a retail company and you, let's say, sell 1,000 products out of 1,000 outlets, the most granular form of forecasting or business management which you need to do is probably by product, by outlet. But 1,000 products across 1,000 outlets mean a million forecasting model, 1,000 into 1,000, right? Now that scale is difficult for you to get to. Now, as we look at it in the cloud kind of a scenario, you would probably see that you consume a significant amount of cloud services. There are different kinds of projects which teams globally or in different departments are going to do that. Maybe you have different kinds of cloud vendors, maybe multiple vendors. And lastly, you've got complex contracts with these vendors, which talk about committed volume-based consumptions or, things like that. Now, all of that make it very, very tough for you to not just predict the spend accurately, but also go down to the most granular level to find out who's consuming what and what scale to be able to manage that better. Now, a combination of all of these basically leads to low agility because you can't change yourself fast enough with business changes or changes as your cloud economics or business imperatives ask you to. So that brings us to the whole challenges with forecasting cloud usage. So first, most companies don't have specific internal protocols and guidelines, to be able to forecast what would they be spending in the next 1 month. Most companies do kind of have a monthly cycle for cloud spends because that's how you get billed. Rarely does anybody do weekly or daily. Those are different use cases for forecasting. But really, you would like to know how much are you spending by month and by quarter and annual. Should you remain with a budget? Are you able to allocate cloud resources and budgets to your separate teams or separate projects? So there are no specific guidelines around this. This is an emerging field. You don't have visibility into the future. Obviously, there are no cost metrics to track. What is good, bad, ugly? How much are you faring on a monthly, quarterly, yearly basis against if there are any metrics given to you? And then, of course, that leads to cloud costs, spiraling out of control. Companies are also often conservative when sizing for cloud commit. Essentially, when you do your contracts with your vendors, a lot of companies do negotiate and basically are conservative on their commit. So basically, that is due to the fear of being overcommitted on spend. So most companies try and just commit to baseline loads. So much so, in my experience as well as a rule of thumb, committed spend is often 20% lower than the actual spend. So almost in majority of the cases, companies do end up spending more than what they have really committed on a contract. This can go as high as 2x as well. So actual spend is often higher than committed. And this is not even so this is just the resources which are committed, right? We are not even accounting for the cost, which actually, are overages on the basis of elastic prices, because anything which you kind of do over and above your committed spend will probably is charged, more expensive for you. So essentially, And on the other hand, companies, at times over provision where, for looking and managing business spikes, they try and over provision the infrastructure, which results in a lot of wastage of infrastructure, which doesn't get used. And that is why there is a dire need for companies to be able to forecast cloud usage on a very accurate basis. Today we are going to talk about building a framework that allows you to have checks and balances, on your cloud costs without disrupting productivity. So essentially, you are able to see into the future that what could be your specific cloud requirements, break it down by the specific services which you might be using, so that you always optimize on your cloud spending, on your cloud provisioning. You're not over provisioning and you're not under provisioning as well. This also leads to better commercial contracts, with your cloud providers or your set of cloud providers, which could result in significant savings. This also allows your organization to scale uninterrupted. You don't need to scamper at the last minute to start provisioning resources. Of course, there is elasticity in the cloud, which is inbuilt. That's why cloud is so popular, but that also has a cost attached to it. And hence, we are talking about cost and infrastructure optimization. And of course, finance managers love this, that you are able to budget it precisely and stay within that budget there. So it's a real P&L impact. And essentially, the larger the company, the bigger this problem today. So with that, I'll probably now hand it over to my colleague Sanka to take you through a real life demo of how this really looks and works like. We are probably, think about it, as a large company. So we've implemented this with a large company, one of the largest retail companies in the US. They're also one of the large consumers and spenders on cloud, basically hundreds of millions of dollars. They have usage and volume commits, and they did have a big challenge on not being able to know how costs are changing from a coming month, right? If you have a very large contract and you have almost unlimited supply of cloud resources, you tend to kind of ignore how much you're consuming, resulting in a lot of either cost wastage or resource wastage. Budgeting was a challenge, and then staying within the budget was a challenge. So how do we take that forward? I'll hand this over to Sanka to take it forward from here. Sanka, all yours. Sanka, we can't hear you in case you're speaking.
Hi everyone. I hope you can see me and hear me.
Yes.
All right, cool. Yeah, thanks, Mohit. So I'm Sanka. So let's do a quick demo. I'll try to make it maybe 15 to 20 minutes. So we'll have about 15 minutes left for any Q&As. I hope you all can see my screen as well. I have shared sort of a web page.
Yes, Sanka, we can see your screen.
All right, cool. Right. So please feel free to post questions during the demo itself. I'll try to take some breaks during the demo itself to answer some of those questions, right? And at the end of the demo, as Asangi said, we'll basically let people ask questions as well. So let me start. So as Mohit said, right? Mohit said most of the new age tech companies are cloud native. So we are also one of those companies, right? Right. We are born in the cloud. This product FORECAST², right, which is obviously it's implemented in cloud. As Mohit probably mentioned, right, people when you think about forecasting, right, you think about retail, FMCG, demand forecasting sort of use cases, right? Obviously, those are the common use cases, right? Everyone have been doing that. So when we were actually working with a big retailer, right, as a sort of a adjacent, but probably as a big problem that they wanted to solve in terms of forecasting, right, came up, and that problem was this cloud cost forecasting. So we, frankly speaking, right, we also got to know about this problem through our customer. So let me just start the demo just to provide some context. What we are trying to do here is trying to forecast the spend on a development environment, right? So in cloud, right? So you would have the production environments, you would have some staging sort of environments, and you would have development environments where people use for development related activities, right? Some of these are new projects, right? Some of them are pre-production, certain development work. So what we're trying to do in this particular demo is illustrate how you can probably forecast the spending in a development environment in cloud. And so let me just jump on to the demo. So I'm actually on FORECAST². So let me just open a data set that I'm going to use for this demo and maybe quickly take you through data. Sorry, it's quite small, I guess. Let me try to make it a little bit larger. Right. So here the example is quite straightforward. We sort of took a simplified version for this particular demo. So we have obviously the timeline, right? So you will see months, right? 2018 January, 2018 February, so on and so forth. So the granularity of this data set is monthly, right? And this is what we want to forecast, right? I'll go to the very end of this data set because here we are actually trying to forecast at service level. So there are obviously multiple cloud services that you consume, right? Some of them are obviously, most of the spending is obviously on the compute related services. But there's obviously storage and other API, other monitoring sort of services offered by cloud providers. So what we're trying to do is, even though eventually what we really want to know is the total spend, when we actually break this in, it gives more visibility and it tends to be more accurate as well. So as a result of it, we are actually forecasting each of these services separately, and then we are aggregating up to get the final number. So this is sort of bottoms up forecasting, right? If I just adopt the retail language. Right, so we talked about the granularity, which is monthly. Cost is the variable that I want to forecast. These are the predictors, right? So if you just do it without thinking about the predictors, what will happen is, you will just look at historical trend and seasonality, and then you will try to get the forecast. But in a situation like that, that can be ridiculously wrong, right? Because these things are evolving quite fast, right? So you just can't look at the history and try to forecast what's going to happen in the future. So we have to bring in other factors, factors that will actually influence your cloud spend. So here in this simplified example, we've taken a few factors. We've taken the number of users who are using this development environment that I talked about, right? So that's this predictor variable here. We've looked at the number of hours that these users have put on this particular development environment, right? So we've taken that as a predictor. And there are obviously in a development environment there can be multiple projects that's concurrently happening. So we, just to bring that information as well, right? We've taken a number of projects, right? So we've taken, we've taken a quantitative approach, right? And there are other qualitative factors, right, that can actually influence, right? I mean, just maybe number of projects is not enough, but as a starting point, right, it's a good place to start, right? So I think right, and as the last variable we've taken the commit as well, right? So you basically most of companies, right, they commit to a certain amount of minimum spending, right? So we've taken that as a predict as well. So these are the predictors that we are going to use for our demo purposes today, right? So this is the structure of data. Again, as I said, FORECAST², right? It does not sort of you don't have to stick to these variables. It's very flexible, right? You can bring in your own variables, your own predictors, right? And the system, will do custom built modeling based on the predictors that you take in, right? So none of this is predefined by any means. It doesn't need any external configuration or anything like that to bring in other variables, right? You can just bring in by input in new variables. So this is the data structure, right? And as I said, just feel free to type in if there are any questions. I'll try to answer during the demo itself. So with this data, now let's go into doing some modeling and training using FORECAST². Right, so let me just open the same data set here. Let me zoom in a little bit. Right, now here a small magic has happened. I talked about, right, we want to forecast at the service level. Now you can see, right, this, right, this screen is sort of automatically self-organized, right? So each row here is a forecast, right? So this is the app engine, right? BigQuery, right? Right, I think this gave away the cloud provider. Compute, right? So on and so forth. So each of these rows is an individual forecast itself, and we are trying to do a custom model, right? Custom forecast for each of these services. Now, to get a forecast, there are few steps, right? But it's actually very easy, right? You don't have to be of a data science background to do this. FORECAST² is a tool. It can be a tool for a very non-technical use as well. So if you want to train a model, right, all you have to do is, right, just select what you want to do, right? That's one click. And just hit on this train button, right? It's as simple as that, right? We've done our best to make the workflow as simple as possible. The complexity of the training and everything, it happens algorithmically in the backend, so the users don't have to worry about all of those stuff, right? They can just select what they want to train and just hit the train button. It's as simple as that. And for this illustration, I'm only training, I only selected one, but you can, select hundreds of forecasts, right? So everything that is listed down here, right? You can, just train everything at once if you want to. I'll just probably spend, right? Probably there are quite a few technical users here as well. I will spend a little bit of time explaining what's happening in the backend. Now, if you give a forecasting problem to a data scientist, right? So data scientist will take it, right? So the first thing the data scientist will do is, look at the data, try to look for, right, some abnormalities and things like that, outliers, right? Basically do some pre-processing cleaning, right? So what we do is in the algorithm, we take the data, we do the same thing, we do, right, automatically we try to detect outliers, and based on that, if there are outliers, we smooth them out, we sort of exclude them, we impute them, we do all of that automatically, right? Then they would do is, right, they would break the data into training and testing, right? They will take the training data set and they'll do certain amount of feature engineering, right? So features are the predictors that we talked about, right? What will actually influence your forecast, right? So they will try to massage some of these features, right? Create some features, right? So that is what they will try to do, right? So we will try to do all of that. We will actually look at multiple features, right? And we'll just keep them aside, right? So now you have a sort of a massaged clean data set, you have features, right? And then, right, in forecasting, there's no silver bullet algorithm, right? So it's not like, the same algorithm will work equally well for all kinds of forecasting problems, right? So for all forecasting data sets. Now here I have, about 10, different forecasts, right? Now there's no guarantee that, a single model or a single algorithm will perform equally well across all these 10 data sets, right? So we have to basically, right, go through all these different algorithms, right, and try to select the best one, right? And when you look at all these different algorithms, right, there are many different algorithm classes, right? So there are, you get obviously classical time series models, right? If remember a little bit of your, statistics, undergraduate statistics, right? There's, classical models like ARIMAS, SARIMAS. Then you obviously have the machine learning algorithms, the tree-based algorithms like, the random forests, the XGBoost of the world. You can have some deep learning algorithms for forecasting as well. You can have, and there are third-party algorithms as well. Like as an example, Facebook published their forecasting algorithm 2 years back. It's called a Prophet, right? So if you want to really try to find the best one, you should do this. You should try to train the model across all these algorithms and you should try to select the best one, right? But it is almost impossible to do that, even for one data set, right? And imagine having to do that across, hundreds of different data sets, right? So that is why I think this comes down to the scale problem that Mohit talked about. That's why lots of forecasting problems, even though it needs scale, right? The current right technologies or the current practices cannot deliver the scale. So this system basically, right, since we are doing it algorithmically, of course, we can sweep across thousands of different candidate algorithms and we can select the best one. So it does all of this, right, what data scientists, a very good data scientist would do, and we can do it even more, right, using an algorithm. So that's the premise of forecasting algorithm behind FORECAST². Now, I think this model training must be done. So let me just refresh. Right, it's done. Now, you can just look at some KPIs of my training. Now, these KPIs are obviously, right, I said that, we would, leave aside a little bit of data, which we call as testing data, right? So these accuracies are based on the testing results, right? So I will actually not go into all the small details because, probably we don't have that much of time. Just one small thing I want to show for a technical user, right? Maybe if you're someone who has an idea about these different ways of forecasting, right? We have expert options panel, right? Again, I think in the interest of time, I will not go through all of it. I'll just so you can actually select some of these algorithm classes, right? So here I have actually selected some only machine learning, deep learning class, and time series traditional class. Now within each class there are 5-10 algorithms, right? So and within each algorithm there are another 3-4 parameters, right, that we can calibrate. We call it hyperparameter calibration. So all of that, right, happens automatically. But if you're an advanced user, right, you can actually restrict the model selection into few classes. You can, as an example, I'll just talk here. Here you can add holidays. If holidays is a predictor, right, you can just select that and select the country. So there's a holiday package obviously, and right, so we can automatically pick the holidays for that particular country. You can play a little bit with the features, right, and there are few advanced features that sort of a more technical user will appreciate. So you can do that, but that is not part of mandatory workflow. Now I have trained a model, right? So that piece is done. Now the second piece is right, getting a forecast, right? So if we want to get an accurate forecast, if we can tell the system about the behavior of the future behavior of some of these predictors that we have used, it'll of course give us a much better forecast, right? Because, right, look at our predictors, right? Our predictors are things like the number of users, the number of projects, right, and things like that. So if you are planning to start a new project, right, so you can tell that to the system, okay, my current number of projects is 10, it's going to be 12 from next month onwards, right? And I expect, right, this many project hours, right, to be put by my development team, right? So you can input, because these things that are things that you actually plan in advance, right? You do right, planning around this, right? So you can actually tell the system what you're planning to do, and once you tell that to the system, you will actually get a much more accurate forecast, right? So the forecast will actually reflect the reality, right? But for this particular example, I will actually not go into too much details on how we can do this. I'll just there are predefined options. I'll just use a predefined option here, which says use historical values, which basically means, right, none of these factors, I'm not going to change anything, right? Just use historical values, right, for future forecasting as well. So I'm just going to adopt that option for this example. And there are, as you can see, there are other options as well that you can select from.
Sankar, there is a question which says that how do you select the best model? Is it only based on accuracy, or we can base it on different performance measures?
Right. Yeah. Thanks. Yeah, that's a good question. So the standard selection happens based on RMSE, but in that expert panel, there are other accuracy measures, other selection methods like percentage error based selection as an example, right? So you can actually right, we have given some predefined options, so you can select out of them. The default selection happens based on mean squared error. Good question, actually. So we will actually keep adding some of these selection methods. Right now we have 3. And it's based on, obviously, it's based on the testing data set. Yeah, so let me just use historical values to set my predictors. All right, so now I have trained a model. So I actually trained this model, and I have set my predictors, how what I have planned for the future. Now I know I have given that to the system. Now my last step is, just generating a forecast. Again, it's just selecting and, hit in this forecasting button. And now I should have a forecast. Getting the forecast won't take time, just a few seconds. Right, now I have the forecast. My forecast starts from February 2021, right? And so this is my forecast. The forecast horizon it's 12 months from the current date, right? So since we are in June, it gives a forecast till 2022 May. This is quite small. This is actually May 2022, if you can see. Right, so that is the basic flow of doing a forecast, a multivariate forecast using this system. Of course, you don't have to do any of this one by one, right? As I said, you can do these selections at a global level if you want to, right? Everything that I showed, right? You can do it at multiple levels. If you want to do it at a global level, you can do it at a global level. So the workflow wise, right? It's exactly the same, right? Between getting a forecast, getting one forecast, or getting 200 forecasts, right? So that's the basic workflow of getting a forecast, and I'll basically take another maybe 3-4 minutes to conclude this. Just let me just show you, some standard visualizations, right? So
Sanka, in the meanwhile, there's another question. Is parameters of forecast models auto-selected, or do we need to define it?
Right, so parameters, I think what you mean is hyperparameters. If it is hyperparameters, no, you don't have to do anything. They are automatically auto-selected. Hyperparameter calibration happens automatically. We look at multiple possible values for these hyperparameters, right? So that's why we actually look at tens of thousands of different combinations, right? Which is obviously cannot be done manually. Right, so all of that happens automatically.
If you, but influencers of the forecast or the predictors of the forecast, we can obviously.
Correct. So if you meant influencers of the forecast, right, you can manually select them, deselect them as well in expert options, right? That's one option. But if anything is a non-influential or insignificant, right, statistically speaking, the model will automatically spit them out. So both things will happen. If you want to worry about it, you can worry about it, right? But you can just ignore that and let the algorithm do the work as well. So let me just show you, like very basic visualizations, right? So now I have got forecast, right? So you can look at each forecast, right? I'll just go to this KPI screen, right? So so you can look at the forecast versus the actuals, right? Growth is right if it is going up or going down, right? For each of these things, right? So you can do all of that. You can aggregate, right? You can aggregate by quarter. You can aggregate by service, right? So you can do all these, slice and dice in here, and then you can export, right? I think you can visualize, right? So I won't go into specific details. Maybe I'll show you maybe one last feature, right, which we call as what if, right? So so I have a forecast, right? So this is the app engine service, right? So the cost for that. Right, so so I have got my forecast based on this many users, right? So this is my So the forecast is based on this many people working on this system, right? I don't know if you can see, let me just try to. So 10 people in February, 9 people in March, so on and so forth. Let's say I'm going to put more resources into this particular function. So I made it 2020, 20 and 20, 20 for February, 20 for March, right? Now I can see, right, what's the impact of my cost based on that, increase of resources, right? So now you can see, right? So this is my baseline forecast, which you can see in dotted lines, right? And what you can see in blue is my sort of scenario where I've, visualized a situation, or I've run a scenario where I, increase resources for a couple of months, right, for a particular service or for a particular project. So I think that's the basic workflow, right? There are many other auxiliary functions around this, right, I think we can, right, we don't have time to go through all of that, but I think I'll conclude our demo at this point, and we'll open the floor for any Q&As. Thanks a lot, guys.
Thanks, Sankar. So coming on to here, just to kind of summarize, the FORECAST² platform was what Sankar demonstrated. It's a horizontal platform. We have very large and medium-sized customers using it for very different things. Demand forecasting is very popular, so the same platform can get used for demand forecasting. We have inventory forecasting, but today's focus was cloud cost forecasting. And like Sankar spoke about, that very large organizations are using this. So the product is basically designed for the business users. The most common users of this product, of course, data scientists love this product because this just enables them significantly and cuts a lot of their stuff, the routine stuff, and helps them build forecasts more intelligently. But a lot of our users are business users. They are marketing managers, IT managers in the cloud use case. They are finance people, demand, business analytics kind of people. They use that. It's simple, click, drag and drop. As you saw, data ingestion is not a problem. Adding influencers of the forecast is not a problem. You can add as many of them. The system is intelligent enough to tell you where data is not enough, or wrong data, or wrong formatting, etc., etc. And then, of course, it allows you to build machine learning models. You are actually transparent to the fact that there is machine learning model building happening at the back end. But what it allows you to do is that it continues to learn from the data. You can add additional data, real-time data, and it continues to take that, build better models, and give you more accurate forecasts. With that, we would open the floor to questions. Sangi, if you can, kind of allow people to talk, or would you prefer that they put the questions on chat? That's okay as well. There are email IDs on the screen. Anyways, you should feel free to talk to us in case you have any questions later. We would welcome all of you to reach out to us. Would be happy to do a specific demo. If needed, if you have a specific problem, we'll be happy to, brainstorm with you and solve that problem as well. But happy to take questions right now. We have about 5-6 minutes for the same.
If there's anyone interested in asking a question, please indicate that you have a question. You can raise your hand and I will unmute you.